Today we are solving Winter 17 paper 31 question number 9. So it says the diagram shows the curve this for x is greater than or is equals to 0. The shaded region R is enclosed by the curve, the x-axis and the lines x is equals to 0 and x is equals to 2. So for the first part we need to find out the exact x coordinates of the stationary points. So whenever they ask us to find any coordinates of the stationary point, we need to find the derivative and then equate the derivative to 0. So we will be finding the derivative. So to find the derivative, I'm going to write down the equation again. Now we are going to be using the product rule. The product rule is given in the formula sheet here, UV. This is the product rule given in the formula sheet. So in this case our u is 1 plus x square and our v is e to the power minus 1 over 2x. So now we need to find out the derivatives of u and the derivative of v. So the derivative of u would be 2x because the derivative of 1 is 0 and the derivative of x square is 2x. And the derivative of e to the power minus 1 over 2x would be minus 1 over 2 e to the power minus 1 over 2x. Now we are just going to input our values into the formula. So I'm going to do it with a black pen. Our derivative is equals to v. So our v was e to the power minus 1 over 2x multiplied into du over dx. So du over dx is 2x in this case plus u is 1 plus x square multiplied into dv over dx. So the derivative of v, and the derivative of v is minus 1 over 2 multiplied into e to the power minus 1 over 2x. Now we are just going to simplify this and we'll get the derivative. So when we simplify, this is what we'll get. Sorry, it will be a minus. So this is our dy over dx. Now to find the x coordinates, what we have to do is we need to equate our dy over dx to 0. You can see that 1 over 2 e to the power minus 1 over 2x is common in all of these. So we can take it as common to simplify our equation. So 1 over 2 e to the power minus 1 over 2x is common. So I'm taking it as common. Simplify it further to find the x values. So to simplify, we can do 1 over 2 e to the power minus 1 over 2x is equals to 0, and we can do 4x minus 1 minus x square is equals to 0. So for the first one we won't get any value, the answer would be undefined, so we won't consider it. For the second one we can solve the quadratic equation like this. You can simply input the values into the calculator and find out the values. So once we'll input the values, we'll get two values of x, and those two values will be our answers. And these are the two x coordinates of the stationary points. Now moving on to part 2. For part 2 it says that show that the exact value of the area of R is this. So to find the exact value of the area we need to integrate the curve equation which is given. So let me just draw a line here to separate. Okay, so the curve equation is given. We are going to integrate the curve equation. So it will be 1 plus x square e to the power minus 1 over 2x. Now for the values in the figure we can see that there are two x values. It starts at the starting point which is 0 and it is ending when x is equals to 2. So 0 and 2, these are the two limits we will be taking. So now I'm going to simplify e to the power minus 1 over 2x by multiplying it. So we'll get e to the power minus 1 over 2x plus e to the power minus 1 over 2x x squared. Now we can individually integrate them. So we are first going to integrate e to the power minus 1 over 2x. So we can integrate it like this. You will have to use the rules of integration for this, and this ends up with minus 2e to the power minus 1 over 2x. So this is what you get when you integrate this. So this is the first part. Now we need to integrate e to the power minus 1 over 2x x squared. So I'm going to integrate it separately so it's easier to understand. Here we are going to be integrating e to the power minus 1 over 2x x squared. We are going to integrate it in parts. So the formula is given in the formula sheet right here. This is the formula which we will be using. uv minus v du over dx. So this is the formula which we will be using. So in this case our u is x squared, dv is e minus 1 over 2x. So once we integrate e to the power minus 1 over 2x, we get minus 2 e to the power minus 1 over 2x. So this is our v, and derivative of u is 2x. Now we are going to input these into the formula, and the formula was uv minus v du over dx. Okay, so u is x squared in this case. Our v is minus 2e to the power minus 1 over 2x. v is minus 2e to the power minus 1 over 2x multiplied into du over dx, and du over dx is 2x. So here we get minus 2 minus 1 over 2x x squared minus, now I'm going to multiply these so it is easier to integrate it. So we are left with this is what we have to integrate again. So now we are going to integrate minus 4e to the power minus 1 over 2x multiplied into x. So it will be something like this. Now I'm writing down the steps on this side so that it's clear. Here we are going to integrate this. So u will be x, our dv would be e to the power minus 1 over 2x dx. So v would be minus 2e to the power minus 1 over 2x, and the derivative of x is 1. Now we are going to input into the same formula uv minus v du over dx. So u is x in this case, our v is minus 2e to the power minus 1 over 2x, our v is minus 2e to the power minus 1 over 2x, and du over dx is 1, so I'm not writing it as it doesn't really have any effect. Dx. Now minus 2e to the power minus 1 over 2x minus, here we can take minus 2 outside so it's easier to integrate. So we are only left with e to the power minus 1 over 2x to integrate. So we know that when we integrate e to the power minus 1 over 2x, we are left with minus 2 e to the power minus 1 over 2x. Minus 4 e to the power minus 1 over 2x. Okay, so this is what we get when we integrate e to the power minus 1 over 2x multiplied into x. So this is the answer. Now we need to put it back into this equation which we were solving earlier. So I'll write it down again. Sorry about this. So I'll write it down again. I'm going to write down what we got as the answer after integrating e to the power minus 1 over 2x multiplied into x. Okay, so we got minus 2 e to the power minus 1 over 2x multiplied into x minus 4 e to the power minus 1 over 2x. So this was our answer. Now we can simplify it further by multiplying 4. So we'll get now this is what we get after we integrate. This is what we get after we integrate. Let's just go back. Yes, we were integrating e to the power minus 1 over 2x multiplied into x squared. So I'll write it down here. E to the power minus 1 over 2x x squared. This is our answer. Now we are going back to our first equation which we wrote. It is right here. Actually, I'm going to write it down again so it's easier. Now here, so our actual equation was e to the power minus 1 over 2x plus e to the power minus 1 over 2x x squared. So I'm going to write down the answer right here. I'm going to simplify it, and yes, we can't forget our limits. They were 2 and 0. Now we can substitute the limits x is equals to 2 and x is equals to 0. So first we will substitute x is equals to 2. So I'm going to change the color. So minus 2 e to the power minus. So when we multiply minus 1 over 2 into 2, we get minus 1. Minus 2 e to the power minus 1, and x square means 2 square, so 2 square is 4, so multiply into 4, minus 8 into e to the power minus 1 into 2 minus 16 e to the power minus 1. That's it. We have to subtract it. Now we are going to substitute x is equals to 0. So it will be minus 2 e to the power 0 minus 2 e to the power 0 and 0 square minus 8 e to the power 0 and 0 square. So it's just 0 minus 16 e to the power 0. And now after solving, we should get the answer as minus 42 e to the power minus 1, and after solving this, our answer should be minus 18 So in the end we'll get minus 42 e to the power minus 1 plus 18. So minus 42 multiplying to e to the 1 is the same as minus 42 divided by e, and we can just rearrange this equation, so it will become 18 minus 42 divided by e, which is our answer. So this is our answer.